Woohoo!
Shoshana is currently serving as the president of the New York City section of the Illuminating Engineering Society, IES, and is an active member of the Lighting Controls Technical Committee, which develops nationally recognized standards for lighting control. She is a professional member of the International Association of Lighting Designers, IAD, and is among the first professionals in the world to earn the certification of
Easy for you to say.
Certified Lighting Designer, CLD, having demonstrated mastery in 7 domains of lighting design as established by the CLD Global Organization and the ILD. Ms. Siegel is a senior designer at Hercraft Lighting Design. Welcome.
Thanks. Hi, everyone. All right. So first of all, if you were here earlier, I apologize. You've already seen half of this, so you can take a nap, and I'll wake you up when we get to the new part. Okay. Here's the placement. Here's the thing. Here's the things you're going to learn. So the first thing we're going to do is we're actually going to speed through. First we're going to talk about acoustics and why everyone needs soft surfaces in your rooms. And then we're going to speed through a sort of very basic primer on control just to make sure that we're all defining our terms at in the same way. So this is a really good question. What is control? Okay. So when we talk about control, we can be talking about very carefully crafted visual environments. We can talk about lighting used for placemaking and for wayfinding. We can talk about lighting used, or we can talk about technology that's used to balance the light output from sources from different manufacturers so that they work seamlessly together. We can talk about code compliance. We love codes. We can talk about lighting that relates to or responds to external stimulus to help us stay entrained with our circadian rhythms and what that means. And we can talk about lighting that interfaces with other systems within the built environment for automatic demand response or other sorts of sort of cross-pollination. And finally, I don't want to say finally, but we can also talk about lighting as it responds to AV and other systems like that. So far, so good. So in the year 3, when dinosaurs roamed the earth and I started working in this field, control systems were really very simple. The relationship between the control device, in this case the switch, and the load, in this case an incandescent light bulb, was a piece of wire, right? A physical connection that went from one to the other, called a switch leg. And in fact, control groups or zones or channels were defined by the way that fixtures were wired together, okay? This led to some really beautiful installations. Today, the control systems that we have, even though we're using newer sources, you'll notice these are LEDs, not incandescent A lamps, are actually, many of them are still related to those same systems. And you can tell that because let me go back. Because here you can see we've identified the colors of the wires, right? We're physically wiring a control device, in this case, a switch. There it is, a dimmer switch, to a driver. The driver simply stands in for where the fluorescent ballast used to stand, right? And we're coming right back out with wires. So essentially, within the electronics of this, there is a connection between the gray and purple dimming wires and the black and white switched legs. Everything makes sense? Okay. Today's current systems rely on slightly more advanced and slightly different technologies. We have over here, this is a DALI system, which stands for Digital Addressable Lighting Interface. We'll talk briefly about what that means and why that's important. But you can see here, these are shades. This is an occupancy sensor. Here's a projection screen. Here are all of the lights in a conference room. Here's electronic glass or electrochromic glass. There's a whole lot of stuff going on here. And then we also have over here a system that is designed to control things wirelessly. So since we have a digital source now, and we have basically teeny computers in each little teeny tiny lighting instrument, we are able to talk amongst computers, and that makes the whole system work a little bit more seamlessly. However, we still have the same components. So I'm going to stop for a minute and say that you should go downstairs and see these fixtures. They are amazing, they are gorgeous, and they are red list free. That's all I'm going to say about that. But I'm also going to point out that we have fixtures, we have switches, and we have sensors. Exact same equipment that we had before, just we have it now. The sensors, and sensor-based control is sort of the most basic level of control that we have. Sensors can be either integrated into fixtures, you can see one here, here's another picture of one, or they can be mounted on walls or on ceilings. So let's talk about the kinds of sensors we have and what that means. Basically, the most basic sensor is an occupancy or vacancy sensor. And we're going to talk about the difference between them or among them in a minute. We have two kinds of occupancy/vacancy sensors. And one is a passive infrared, that's PIR. The other is ultrasonic. Those of you who were here earlier heard me talk at great length about why it's important to have dual technology sensors in anything that has any more complicated architecture than an open plan space. The reason is that while a passive infrared sensor, looks at objects and takes readings based on whether or not there's a clear line of sight between the infrared beam and the sensor, an ultrasonic sensor works similar to sonar. The two together allow you to capture most occupancy or vacancy in most types of spaces. If you need any kind of example of why this is important, think occupancy sensor and public restroom. Enough said. Okay, so what is the difference between occupancy and vacancy? First of all, well, before we get to the differences, let's talk about what it is. I'm so sorry. All right, occupancy and vacancy are the most common reasons we use them are for code compliance. They are the simplest way to meet code in terms of energy usage. Usually it's between 50 and 30% of reduction in unoccupied area. They supplement other functions like time clocks. And either approach, occupancy or vacancy, will meet almost all codes. Most codes actually do prefer vacancy over occupancy, and we're going to talk about why right now. Okay, so occupancy is auto-on, vacancy requires initiation. What does that mean? I'm actually going to show you. I said I wasn't going to use my samples, but I lied. All right. I'm not going to point these at you because they're really, really bright. They're what I would call multifamily specials. They're little wafer lights, and I can show them to you again in a minute. But this is an occupancy sensor, right? Something happened. The sensors sensed something was going on. The light came on really, really bright and in my eye. Let's cover it up. This sensor is designed for vacancy. It's set to vacancy. They're exactly the same pieces of equipment. Well, this particular one is a hallway sensor, but it's been set to be vacancy, and I'm going to show you, there's a little button here on this particular model where you can hold it and count to 3, and it will reset itself. So you'll notice that I'm waving this around, nothing's happening. What I can do, though, is I can pick up my little wireless pad, and I can turn it on, and now once again, I hit myself in the eye with this. You would think I would learn. All right, so that's the difference between occupancy and vacancy, and that's what I mean when I say that one of them requires initiation and the other one doesn't. All right, let's go back over here. Oh, here we go. All right, so vacancy has a timed off. I don't know if you guys can see that this is still on, but if you just sort of watch it while you're also listening to the thrilling things I'm going to continue saying at you, you'll notice that eventually this will time itself out and it'll just go off. Vacancy will do the same thing. Amazing. There's no interface required with occupancy sensors, right? You saw I picked up the switch, I picked up the sensor, the light came on. That's all you need. With vacancy, you have to have an interface. The cool thing is about this, and this is again another reason that many codes prefer vacancy actually, is because since you need one to override the off state, you also then fulfill the requirement of a manual override, which shows up a little bit in a couple paragraphs further down in the code. So it's sort of a 2-for-1. The problem with occupancy is interference from surrounding areas, which we don't have with vacancy. Why? Because if I pick up the sensor again, the light will come back on, and then we'll have to wait 10 minutes or however long it takes for it to go off, right? So when people complain that every time somebody passes outside my window, the lights come on, that's what they're talking about. They're talking about the adjacency issues with occupancy. All right. Daylight harvesting, second most common and also code required method of control. Why is it, how does it work? What are we going to talk about? So first of all, it's based on the amount of the window or other glazing area. So that could be a monitor, it could be a skylight, it could be a window. And the wattage used in the space. So it's approximately 600 square feet, give or take, depending on the specific code you're looking at. And then I believe it's 100 or 150 watts. Okay. Daylight harvesting establishes what are called daylight control zones. And it's designed to balance the free daylight and the electric light that we're paying for. That all makes a lot of sense. So there are two basic kinds of daylight control sensors, or two daylight control systems, open loop and closed loop. So you can see here, this is an open loop system. Basically, the sensor is reading the amount of light that's coming in the window, and it's modifying the amount of light coming out of the fixture, the luminaire. In a closed loop system, the sensor is reading the amount of light on the work surface and modifying the electric light to make sure that the work surface maintains a specified illuminance. Guess which one I like better? Closed, right? Because in the closed loop situation, you're looking at actually the surface that you're dealing with. Whereas in the open loop system, you're only looking at what's coming in from the window, and that may or may not be useful depending on where your window is relative to your desk. So let's look at this for a minute and just look at this sort of more holistically. First of all, instead of 1x4s, pretend these are really cool, sexy, direct, indirect, linear pendants. This is an open office, I know. I couldn't find a really good diagram online, so this one looked pretty clear to me, so I figured I'd just ask you guys to imagine. So pretend that these are all linked together. You have 16 feet of fixtures stretching out over a beautiful open plan office. We have 3 daylight zones. We have the primary daylight zone, which is right here. That's the one that's closest to the window. We have the secondary daylight zone that it's sort of self-sufficient what that means. And then we have this skylit daylight zone, which you don't see often. Well, let me rephrase that. In New York, where I do most of my work, you don't see often because we don't have that many skylights except on the top floor of buildings, and even then, not so much. In other spaces, in other parts of the country, you might see this more frequently, and you do then have to figure out how to balance the amount of light that's on a work surface between all 3 of these zones. So, what are the issues? There are overriding issues. There are override issues, which is to say people jam the sensors because they don't like what they do. There are shades. There's the fact that you can't control clouds, and there's missing teeth. Let's talk really briefly about what those mean. Oh my goodness. Override issues, that's pretty straightforward. The lights are never on when I want them to be on, so I'm going to find a way to game the system. Anybody who's ever walked into a space, and I should have included a great site visit shot that I have that showed somebody had opened up a packing box and taped it over the window and then brought in a lamp from home with a shade and stuck it on their desk. Tons of energy being saved right there, I got to tell you. Okay. Then there's the shades. Shades can either be manual or automatic. Guess which one is more expensive? And therefore, which one never gets installed? Because manual shades are the norm, it means that your office mate is in control of the amount of light on your desk. And everybody has an office mate who's that person, right? We have all worked with that person who can't stand the amount of light. They're moles, they can't stand the sunlight, or they're precious snowflakes, they might melt. So shades are an issue. And when you put the shade down, what does it do to the daylight sensor? Well, if the system has been properly commissioned and properly set up, at the very least it should disconnect the daylight sensor. Sometimes that's not the case, and sometimes that sensor is actually on the exterior of the building, and then you've really got a problem, right? You've got a shade that's blocking the daylight that the sensor is still reading, so that works out super well. Can't control clouds, we all know what that means. If a cloud comes across and the daylight drops, like a sudden summer thunderstorm, you often have issues with the amount of light on a work surface. All of this is to say, by the way, is not to say that daylight harvesting is a bad thing. It's just something, these are all aspects you need to think about and allow for in your control specifications, which we're going to talk about in a second, in order to make sure you don't get caught. And the missing teeth is my favorite. So imagine for a second that we have these three 16-foot runs of fixture, right? Here's 1, here's 2, here's 3. This one, what do you imagine its state is most of the time? It's furthest away from the daylight. What does it look like? Sorry? It's on, right, it's on. That was the right answer. All right, now, how about this fixture? What's it doing? Probably. The first 8 feet of it are kind of on. Let's say it's at, I don't know, 50%. The last 8 feet are not, right? Because it's directly underneath the skylight. It's in the skylit zone. So when you get off the elevator and you look at this beautiful, gorgeous, sexy, open plan office, because those are all adjectives we use to describe open plan offices all the time, what do you see? You see, let's say it's a direct-indirect fixture and you manage to get the indirect part on all the time, right? The indirect is not being controlled by the daylight sensor. Good luck with that. Now what do you have? Now you have a really bright ceiling, and you have one half of the fixture that is noticeably darker than the other. And then over here, it's going to happen again. So the thing to do with daylighting, in my personal opinion, my professional opinion, is you should always over-control. I think that it is better to link the secondary daylight zone to the skylit zone and let the one that is the most impactful control, and then add your electric light on top of it. Because your electric light is there to supplement when the daylight isn't. You could go the other way around too. You could say, I'm going to control for the electric light and let the other one supplement, but I really feel like you save more energy the other way. Does that make sense? All right. Why circadian lighting matters. It's 1:49. Who's ready for a nap? That's why circadian lighting matters, right? So we all know that somewhere between 2 and 3, it's time for carbs and coffee, right? Without fail, it's time for carbs and coffee, and here's mine. So we know that over the course of the day, human alertness and our ability to focus waxes and wanes. And we know that some of that has to do with the way that our circadian system is stimulated by the color of the daylight, the color temperature of the daylight that we have evolved to expect to hit our retinas, right? We also know that this all has to do with a non-visual photoreceptor, which, as somebody in this morning's class reminded me, they now talk about in preschool, which I think is amazing because it didn't exist when I was in preschool. The intrinsically photoreceptive ganglion cell, I think I got all of those modifiers together, did not exist when I was in preschool. Nobody had figured it out yet. And now now 5-year-olds, 4-year-olds learn about it. I think that, to me, that is like science. Anyway, we know that the color of daylight tends to vary. It's very warm in the early morning. It gets very quickly, it gets much cooler. 4,600 degrees Kelvin is colder than this, right? This is about 3,500, I'm gonna say. It stays at noon, very cool, and then it starts fading off. And the goal here is to avoid messing with this natural symbiotic system and to keep us all entrained. The folks at the Lighting Research Center like to say bright days and dark nights. The problem is that night starts at different times during the day, depending on where you are in the seasonal calendar. So bright days and dark nights starts in November. I don't know what it's like in Texas, but in New York, in November, dark nights start at about 2:30, 3 o'clock in the afternoon, right? So our awareness of circadian lighting and its impact on human health is important because we want to make sure that we're not building spaces that are inherently harmful to the people who need to live and work in them. So one of the ways to do this is to tie the color temperature of the fixture whether in this case this is an accent fixture for people's homes or a fixture that's a work light, to tie that to a time clock and or to a daylight sensor that can also read color temperature in order to allow the fixture to move along with what's happening in the exterior world. Make sense? All right. All right, that was the review. Let's talk about how we get this on a project. So we have 3 documents that we really, really, really need to focus on in order for this to work. One is the OPR, the owner's project requirements. One is the control intent narrative, and one is the sequence of operation. But we're going to take each one of these kind of slowly. One of them is going to drop off, alas, a little bit quickly because lighting designers don't write them. Okay, the OPR is the owner's brief for the project. It tells you what the owner thinks they're buying, right? I think it's really important for us to remember that as designers, we're working for this other third party that we sometimes have interaction with and sometimes don't, but they're the people who are ultimately paying the bill. That's the owner. So if the owner thinks that you're building them a roller rink and you are in fact building them a basketball court, that's going to be a problem at some point somewhere. And the way that you can avoid building a basketball court when somebody thinks they're buying a roller rink is to read the owner's project requirements, because hopefully it will say, I want a roller rink. Now, a little bit of caution about this. Owners don't write this. I know it says it's the owner's project requirements. Owners don't write this. Usually the project managers or the owner's reps, or sometimes the construction managers write it. So it's always good to take what's there with a little bit of a grain of salt and to make sure that you ask questions to clarify what it is you're looking at. Okay, the next document is called the control intent narrative. It provides a broad brushstroke view of the lighting control system and what it's going to do. The most important thing about the control intent narrative is that it should be written in English. And when I say written in English, I mean so that your Aunt Betty can understand it. Okay? My mother is a very smart woman. She's a college professor. She has no earthly idea what I do for a living. None. Anytime I sit down to write a control intent narrative, well, not so much anymore because I don't have to worry about it anymore. But when I first started doing these, I always like to think about, could my mother understand? Could this finally be the thing that would let my mother understand what it is that I do for a living, right? Okay. And then there's the sequence of operations. The sequence of operations is arguably the most important part of this triumvirate. They're all really important. But the thing about the sequence of operations that's important to know is that it's contractually enforceable. When a contractor bids a project to plans and specs, this is part of that. None of the rest of this is. So what does that mean? That means that up here where it says, build me a roller rink, if it says down here, we're going to build you a basketball court, and the owner comes back and says, but I wanted a roller rink, if the contractor can point to where it says basketball court, the contractor is home free. And the owner is not getting what they thought they wanted. So one of the things that's really important is to make sure that all 3 of these line up together so that they're all asking for the same thing. Okay, so who does what? The owner's project owner's project requirements are typically written by the owner's team, sometimes in collaboration with the project architect, sometimes not. Oftentimes, they are cobbled together from other projects. So when you see them, it's important to do a quick read through and make sure that they actually make sense in English. Sometimes you will find that they call for electronic ballast for T8 fluorescence. All sources should be 4,000 degrees LED. I mean, you will get sometimes weird sentences like that because they are typically cut and pasted. The control intent narrative should be written by the lighting control specifier, who may or may not be the lighting designer. And that's really important to remember. In projects that I work on with our firm, we specify our own control. You don't have to be a lighting designer to specify control, and you can be a lighting designer without specifying control. That said, somebody is specifying the control, and that's the person who should be describing what it's going to do. And then there's the sequence of operations. Again, the person who specified the system is the person who should be writing the sequence, but that should be in collaboration with the electrical engineer's drawings, and the reason is it's the electrical engineer who has the stamp and who's going to sign and seal those drawings. So you really need to make everything that's contractually enforceable show up on those drawings. Okay? All right, so how do we get started in this process? These topics are going to come up. They stay the same no matter which document you're writing. And this is really kind of important. These questions want to stay the same. If you remember, a minute ago, I said we wanted all 3 documents to align. This is how you make sure they align. You align them by making sure you answer the same question 3 times. So for the OPR, you're looking at why. What is it that the owner wants or needs from the control system? For the control intent narrative, you're looking at what the control system can do or what it supports, the what. The sequence of operations is the how. It's the specific method, the control protocol, the amount of time, the light level, the very specific things that we're going to talk about, that will tell you whether or not you're actually meeting your intent. Okay. Questions? Everybody good? We're moving on.
I did have one question.
Yeah.
The sequence of operations, I missed the part where you said, one more slide down. One more. That one. You were saying at the bottom. Supplier with the EE and the vendor.
Yeah. So the reason that the vendor is important, and thank you for bringing me back to this because I did forget to mention this. The reason that the vendor is important and the reason that you would want to bring in the vendor at this stage is because not all control systems do the same thing the same way, right? So there's a big company that starts with an L and their color is blue. They do things very differently from companies that perhaps have orange as their base color or companies that have other colors like red as their base color, right? Those companies, some of them speak similar languages, and if you needed to meld systems in some sort of weird Frankenstein way, from one system, from one manufacturer and another, as long as they both can speak BACnet, right, as long as they can speak building management system, then you might have a chance of getting them together unless you're dealing with this other company over here with the L. That company over there with the L will not work with any other system. So if you know that manufacturer is the person who's supplying your system, you really, 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 and I cannot stress this enough, really want to make sure that that person has had eyeballs on your spec and that they have committed to providing what you are asking them to do. That's true of any system, right? So when you set out to write a system and you have sort of the basic idea, these are the 5 big things I need my system to do, that's a really good time to send it out to your rep or to whoever works for the vendor who might ultimately provide this so that you can say, hey, I need you to do this. Like, if you need your system to literally stand on one leg and hop 3 times, you better ask somebody if the system can do that before you write it into your contractually enforceable documentation. Because what are you going to do when you get to that point in the punch list and you say, but you need to hop 3 times? And the supplier says, well, I never said I could stand on 1 foot and hop 3 times. I can hop twice. Is that good enough? I don't know. Is it? All right. Other questions before we go on? Okay. Some questions to consider. Which spaces are functions? That is pretty straightforward. Which spaces are you controlling? When you write a control intent narrative, you want to at least touch on every type of space. So if you have big offices and little offices, you want to have a section on big offices and little offices. If you have 150-person conference rooms and 20-person conference rooms, chances are they're going to behave slightly differently, and you want to touch on them. What types of technology? Well, we all know that they're LED, because that's what there is. But do they have shades? Do they have 2 sets of shades? Is there a blackout shade and a view-preserving shade? Is there VTC, video teleconferencing, going on? If there is it just normal video teleconferencing, like from the camera on your laptop? Or is it a big system, right? Back in the old days, we used to have rear projection and front projection video teleconferencing systems, and they required different setups different amounts of light, and different ways of controlling things. I suppose we still could have rear projection and front projection systems, although I haven't seen a rear projection system in a minute. How will people or the environment interact with the system? How am I going to make the lights turn on? How is the world going to make the lights turn on? In this case, the environment could be daylighting, right? Is there daylighting? If there is daylighting, what is it going to do? How will I know if it's working? This is a big one because when you go to a punch list, when you go to a job site to evaluate this stuff and to program it, if you don't have a quantifiable way of saying that you're done, you're never done. And if you happen to be somebody who works on billable hours and you're never done, I promise you, at some point, the person who signs your checks is going to have something to say about the fact that you're never done. So you want to know how you're going to be done. You also want to know how somebody else is going to know if you're done. What does this mean? This is about measurement and verification, which is something that you need for LEED and for WELL, which are very popular systems, right? In order to commission a system, you need to let the commissioning agent know what it is they're shooting for. Otherwise, they can't tell you whether or not you've gotten there. Make sense? All right. Well, I made it gray. Okay, here we go. So let's look at a couple of really basic spaces, things that we find in everyday usage. In a private office, what happens when people leave their office? Well, that's a pretty straightforward question. The lights turn off. And what are the controlling variables in what would make the lights turn on or turn off? The time of day and the length of vacancy. So that makes sense, right? If it's nighttime and somebody leaves their office and the lights turn off, do we want the lights to go back on? Probably not. If it's daytime, we might, or we, again, might not. So we're going to see this line right here, simple control to meet code. This is what owners want. I did say that you want to get an owner's project requirements and that you want to read it. 99.9% of the time, it says something like this. Simple local control to meet code. Because the owner, there is no owner on, well, I was going to say there's no owner on the planet, but that's actually not true. But there are not many owners who are going to say, I want the biggest, most expensive, most complex, most whiz-bang system you could possibly give me. And if you have a client like that, hold on to them, do anything they want, and never let them go, right? Simple local control to meet code. So here's the control intent narrative statement. Remember, this is written for Aunt Betty or for my mother. When people leave their offices during occupied hours, the lights turn off after 2 minutes. Pretty straightforward, right? You leave your office, the light turns off. It doesn't say, by the way, whether or not the lights turn back on, but here is where it says whether or not the lights turn back on. And in this case, knowing what we know about vacancy sensors, do the lights turn back on? No, they don't. They stay off. So just to imagine a use case about this, you go out to a meeting, you forget your phone, you pop back in to grab your phone. Do you need the lights to turn back on? Of course you don't. You know where your phone is. It sits in the same place in your desk all the time. Okay, here is the delay, right? So during the operational hours, during the workday, the sensors are going to have a 2-minute time delay. This ADJ is really important. It stands for adjustable. And the reason that we have it is because it allows us to change our mind. And changing our mind is a really good thing. Why? Because even though we've read the owner's project requirements, and even though we are all seasoned professionals and we're really good at our jobs, sometimes we get it wrong. And when you've included the initials ADJ there for adjustable, even in a contractually enforceable document, you have the right to go back and change your mind. You can say, I said it was going to be adjustable. Why is that important? Has anybody ever seen that meme with the little boat that says original contract and the big boat that says change order? That's why. The way to avoid that particular scenario with the little boat and the big boat is to build in the opportunity for you to make mistakes and change your mind. And the way you do that is you say, we're going to get to this later. As long as you say it in the specification in a way that doesn't put an unfair onus on the contractor, you're good. But if you say, I want 35-foot candles minimum on my desk surface, and then you come in and decide that you don't need 35-foot candles, and you want the contractor to, or in this case, the programmer, to readjust the light levels based on what you've now discovered, you're kind of in a bad place. Sometimes. Not always, but sometimes. Okay. So let's look at another example. Hallways. When are the lights on in the hallway? Pretty straightforward. They're on when the building's open. What happens at night? Well, what are some of the things that could happen at night that would change whether or not the lights were on? We could have security sweeps. We could have maintenance. We have cleaning crews. We could have all kinds of things. So here's our owner. Again, as I said, they're not particularly, well, I don't want to say that owners are not interesting. Owners are very interesting as human beings. As people in specification language, not so much. All right. So the lights come back on. You'll notice that I haven't said here how they come back on, just that they do come back on. Now, in my control intent narrative, I actually go a little bit deeper into this, but we'll talk about that in a minute. And in the sequence of operations, we actually now are going to get kind of weedy on this. We're going to say that they respond to time clock cues, that they automatically come on at the start of the day, and that they get lower at night, and that they also respond to occupancy cues, so that during the evening, the lights can turn on when the security operator or the security officer passes through. In this case, this is actually from a project, and at the time that I wrote this, there was still a possibility that there were going to be key switches on all of the buildings, or on all of the floors of the building, and that somebody was going to turn it on. We don't have key switches so much anymore. Those are those things with the little two-prongy things. Does anybody remember seeing those? You have to be old like me to have seen them, but yeah. We don't have those so much anymore because we can now have occupancy and vacancy sensors that are very defined in terms of their beam pattern and can be very specific, almost surgical. Okay, the good news is that you are not alone in the wilderness trying to figure this out. There is a standard. The standard is called ANSI IAS LP16. That's a lovely title. The wordy title is Documenting Control Intent Narratives and Sequences of Operation. So I'm going to pause here to just talk briefly about the document, and then we'll look at actually a project example. So what's important about an ANSI standard is that it's written by a consensus committee. What does that mean? That means that it's a group of people that is pulled together from subject matter experts that is balanced. Why is that important? It's important because laws tend to be written by lobbyists. And in codes speak, we don't want that, right? We want to make sure that we have people who are both users, people who are manufacturers, people who are specifiers, people who are installers, across the board deciding what we need. So I'm not going to say that a consensus committee that's balanced according to the ANSI standard rules is the perfect balance, because it's not. Because it's a cross-section of people who are willing to spend a lot of time writing really, really, really nerdy lighting documents. So that's already a self-selecting group. That being said, it is not something that is written only by manufacturers or only by specifiers or only by contractors, okay? This excerpt from the introduction should give you an idea of the sort of things that this document is seeking to provide. It's trying to give you enough information so that you can start along the right path, and so that you can identify the functionality you need and then make sure that the system provides that. Okay? This is what it looks like. All right, what's included in the document? There's a description of roles and responsibilities. This is crucial because otherwise, how would you know that, for example, as the lighting designer, you're not responsible for the owner's project requirements, right? It has checklists and step-by-step instructions. I mean, it's a pretty decent document, I have to say. Side-by-side examples of control intent narratives and sequences of operations. We're going to look at a couple more of those. Sample text. The most, I think, intimidating thing is a blank screen. So this avoids the blank screen problem. The sample text in this document is not intended to be cut and pasted. And for those of you who have ever tried to buy anything from the IS Lighting Library, you will know that it is very difficult to cut and paste from the IS Lighting Library. That is by design. But it is there to give you an idea of the sorts of things that you might want to include in your own document. Timelines. What do you need to do in DD? What do you need to do in CD? What does it look like in CA? This is important because if you've never written one before, it's a lot intimidating. And then documentation examples. What does a matrix version of this look like? What does a diagram version of this look like? What does a narrative look like? And then also questionnaires for client research. This is actually a really handy dandy little thing because let's just say you are going to embark on this process for the first time and you say to your client, well, what kind of occupancy and vacancy sensing do you want to do? Or how do you want to handle occupancy and vacancy in this office? And they say, what are my choices? So these questionnaires are actually there to help you ask questions that will give you answers that are useful, right? Okay. So they're not the same, the sequence of operations and the control intent narrative. The control intent narrative, as we talked about, uses descriptive language, higher and lower. It should say things like, you can say it should automatically dim. It's written in English. The sequence of operations has specific set points, 30% of full, right? General lighting at 300 lux. Contractually enforceable language. One of the most important things I can tell you is the only verb, and I don't know why, at some point somebody will tell me this, for some reason, shall is the only contractually enforceable word. Would, should, do you know why? Yeah, there's a legal language.
Shall, and lawyers always use shall.
Yes, so yes, that I know. I don't understand why. There's a part of me that kind of doesn't want to know, and then there's a part of me that does kind of be like, but why shall? Why not should? But shall. So let me just say that if you're trying to write something that is going to be contractually enforceable, you should use the word shall. It makes for really, really, really boring reading, and it sounds very strange. If you're one of those people like me who likes to proofread their stuff out loud to see if when I am concerned, like if I've gotten my subject and my object's tenses wrong or whatever, I read the stuff out loud and try to, if it sounds right, then it probably is right. So if you have to go through and use shall all the time, it makes that very difficult. That being said, it will save you and get you in the right track. A couple more details. So you want to be descriptive of the project goals with the control intent narrative, and you want to talk about the specific strategies that you're using, but you're talking about strategies like occupancy or vacancy or daylight harvesting, or you're not talking about specific technical requirements, right? You want to provide a description of the control system that says this is going to be a digital system, it's going to be a computerized system, it's going to have a central brain, it's not going to have a central brain. And you want to, I think, provide a preliminary description of what I like to call lighting control events. Lighting control events are things like when you enter the conference room and push the button, the lights will come on. That's a lighting control event, right? It's you interacting with the system to make something happen. The sequence of operation gives you specific goals or specific options. So for example, you might say in a sequence of operation that the timeout for an occupancy or vacancy sensor is 1 minute with the ADJ like we talked about, and then that when you hit the button within 1/10 of a second, you expect to see something happening. That actually is important because, again, not all systems operate the same way, and some systems have obscenely long timeouts. So much so that you could stand there and wait and think, is something wrong? Before it actually happens. This system over here has this funky thing, which we discovered last night, and I'm going to cover this so that you can see it. All right, so this is vacancy, right? Nothing happens until I push the button, so fine, I'm going to push the button. And now I'm going to turn it off. But, oh, it's not going to do it for me. It has a 10-second timeout. If you get it, if you move it again within 10 seconds, it pops back on, which is a good thing if the goal is to keep spaces from going into the dark. It's a bad thing if you don't know that it's there. And I'm a little bummed that it didn't do it for me. Unless it was on the occupancy. Let's find out if it was on the occupancy. No? All right, well, it had a 10-minute timeout last night, a 10-second timeout last night. Just trust me on that. You want to know these things, and that's part of why you want to have your vendor take a look at your control intent and help you with your sequence before you publish it. Does that make sense? All right. Okay. Okay. So we're going to look at a couple of different side-by-side language things. So on the left is the control intent narrative. This is not one that I wrote, so it doesn't read quite as easily to me as it might read to somebody else. But you see that we've specified that it's going to be energy code compliant, that there's going to be auto on, the lighting is going to come on automatically to the last lighting level, that the lighting is going to turn off, right? The daylight responsive controls are going to automatically and continuously dim the lighting in the window daylight zone. That's about all the detail you need to say on the control intent side, right? And you're going to, the emergency lighting is going to turn full on. I personally don't think that emergency lighting needs to be covered in control intent because it's life safety code and it supersedes everything else. But the person who wrote this, I took this from the book, the person who wrote this likes to include it, okay? Any questions about the control intent narrative and what's going on here? All right, the sequence of operations. So here, this part, the general lighting in each 600 square foot zone, auto onto the last level when occupancy is detected. Does anybody remember what's important about 600 square feet? It's the daylight zone, that's right. So what this is saying to you is that in the daylight zone, which happens to be also other zones, it's when occupancy is detected, the lights are going to pop back on. What's missing from this, by the way, is it doesn't say how quickly the lights are going to pop back on. Just saying. All right. Manual off dim general lighting for all zones in unison with the dimmer switch. Remember I was just talking, yeah.
Not to be a devil's advocate, doesn't that imply it would be immediate?
It does, but that also implies it could be a lot of retina burn, which might not be such a comfortable thing. It also, you could just, it does imply it, but it implies it, it doesn't say it. And so if you were in a situation where you had to convince somebody that the system that you had either met or didn't meet your specification, you wouldn't be on very strong footing because you haven't said what the specification is. That's really my point. But thank you for that. Okay, so here in unison with the dimmer switch, again, that's that time, that's that lag time. So if the lags time is too great, then you're going to have a problem. And what you don't want to have is you don't want to have somebody push the button and then wait 10 seconds. Because in that case, 10 seconds seems like a really long time. Auto off. Within 20 minutes of occupants leaving the zone. Daylight zone here. Continuously dim based on daylight contribution to maintain at least 30-foot candles. And emergency lighting. So let's look at a couple of things that are important here. We're going to look at the auto off when the lighting is on, when the space is unoccupied. So here we've got a clear and specific amount of time that we're going to be willing to wait, right? This gives people time to exit the building. Here, daylight responsive controls. We've said A, what it is, but also that it's adjustable. So that if we decide, for example, that 30-foot candles is either on too much or not enough light on that task surface, we can go back and change it without having to argue with the contractor about whether or not they have to provide somebody to help you do that. I know that sounds incredibly specific and incredibly nitpicky, but when I tell you that I once had a contractor, I did a church recently, and the church had like a steeple, a bell tower. And the bell tower was 4 stories above the street. And when it came time to focus the light on the bell tower, I said, well, when is the lift going to get here? And the contractor said, what lift? And I said, well, how did you think we were going to focus? We're not even talking about control. We're just talking about pointing the lights in the right direction. How, with the lift that we're going to use to get up to the bell tower so that we can point the lights so that they're not, you know, up in the sky, out in the neighbor's patio, whatever. And the contractor said to me, you didn't tell me I needed a lift. I said, I don't have wings, and neither does your electrical sub. How did you think it was going to work? Well, I figured you'd focus it while the scaffolding was up. While the scaffolding was up. Let's think about that for a minute. Scaffolding goes around an object. Light goes through objects, not so much. And believe me when I tell you that it was not one, but several meetings before we were able to convince the contractor that by bidding to plans and specs, and because there was a note in, actually not even in the control section of the, well, this was a fixture specification issue, it says somewhere in my specification that the contractor is responsible for providing personnel and equipment in order to achieve blah, 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 blah. Had I not been able to point to personnel and equipment, it is entirely possible that the contractor would have then back-charged me for a bucket truck on East 74th Street in Manhattan at night with a union electrician. Okay? So there aren't as many examples in control language that are quite as dire as that. That's just a really good recent one, so that's why I bring it up. But you guys now understand the point, right? Okay. So let's look at a project example. So when I want to stop and full disclosure here. When I originally decided I was going to include this example, I was supposed to have been, I would have been either on my way next week or just having come back from starting up this system. So when I said I'm going to use this project as my example, it was supposed to be done. They're moving in November. So we're going to stop sort of in the middle because I can't tell you what it was like to fully vet out this particular system because it hasn't been built yet. Nonetheless, we did go through bidding, and that's in and of itself a certain amount of fun. All right, so this is half a floor in a downtown Washington, D.C. building that has a reputation for being the greenest building in all of the district, blah, 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 blah. It's the Environmental Defense Fund, which is important because why? They have a neurodiversity initiative. They are LEED Gold. This is like, if you're gonna find a group of people that are gonna be willing to go for every whiz-bang thing you can do to make a specification more sustainable, more human-centric, more everything, these are the people to do it for. There was a requirement for a declare label for all lighting fixtures.
And that is?
A declare label is an environmental impact statement. There are two different kinds. There is one that is headed by the Living Building Initiative, that's the declare program itself, and then there's another one, I can't remember the name of the other program, but basically the idea is that a manufacturer should be able to trace back all of the systems that are involved in all of the components that they provide. So a declare labeled fixture doesn't necessarily have to not use any harmful materials, but it has to acknowledge in writing, these are the 3 harmful materials that were used in the manufacture of this product, which is important when you're talking about LEDs because of course LEDs are grown in labs and they require rare earths sometimes, and phosphors are rare earths, and it's not a particularly environmentally friendly process. We also, as I mentioned, have a smart building integration issue in this particular project. There is a manufacturer who recently purchased an HVAC manufacturer, a lighting manufacturer that recently purchased an HVAC manufacturer with the goal of providing these sort of married systems for automatic demand response. I mentioned that earlier. Automatic demand response, or ADR, is when, for example, the conference room that sits empty, the big conference room that sits empty all the time, isn't air conditioned, right? Because why waste energy on an empty room? And there are lots of different ways to make that work. One way is to tie in, and this is the big conference room right here. One way is to tie the occupancy sensors that are part of the lighting code into the VAV boxes that control when the HVAC is on or off. Another way is to tie both of those into the room reservation system so that when you reserve the room and you tell the room that you're going to need 50 people, be able to have 50 people in, then the system knows I need to cool for 50 people in this room. Okay? Daylighting by code. So you can see all around here, these are all windows. I can't really tell, but trust me when I tell you these are all windows all the way around the outside. So you're looking at the architect's interior furniture plan. You see we have open offices here. These are spaces that are called out for open collaboration. We have these little touchdown spaces. We have many, many conference rooms. We have more open offices, another collaboration space. And we have this space, which is sort of the entry sequence and then the main boardroom. Okay? And here's some pictures of what the architect thought it was going to look like. So one of the things that I want to point out, this has nothing to do with lighting control, but it does have everything to do with lighting design, and really, why not? I want to point out how gorgeous this corridor looks, and I want to remind everybody that ain't never going to happen. Right? This corridor is not going to have light on the walls. Why? Because they have lit the corridor with surface-mounted downlights. It is never, ever going to look this nice. Also, as it turns out, this ceiling doesn't exist. This ceiling looks like this. So just in case anybody is wondering what that hallway is going to look like, look back there in the back. That's what it's going to look like. Beware of renderings that show perfect lighting. Okay, not about lighting control, but still about lighting design. Anyway, here's one of our lovely conference rooms. Here's the entry sequence. Again, you can see this lovely, oops. This is the pantry. Here's what we did. We started by developing a family of fixtures. I just said a fixture of families. That was really good. A family of fixtures. This is our conference room pendant. Again, this one is downstairs. You can see it, and I really encourage you to go look at it. This is,
That one is downstairs?
Yeah. This one on the upper left is downstairs. I don't know if this, I can tell you afterwards.
How about you could say it's right near the Aware installation?
Oh, that's a good point. It is right near the Aware installation because it is, as you can see, it is red list free, which is important. All right, this particular pendant, it may surprise you to know that there are 2 manufacturers in the country that make declare labeled pendants, like cylinder pendants. One is about 4 times as expensive as the other one. Well, and there are 3 manufacturers that make downlights that are red list or that are declare labeled. One is a $600 downlight and and their cylinders are not declare labeled. One is a really, really, really value engineered product that typically you would not specify. And the third one is 4 times as expensive. Interestingly, when we decided we were going to do this project, and we decided we were going to also have some tunable white, we also decided we were going to use DALI as a control means, as the protocol for this whole system. So that meant that all of the manufacturers that we specified also needed to be able to provide a DALI driver, which should not be as complicated as it is, but I will tell you that this particular fixture created a huge issue, and this was a control issue. The manufacturer that we used for this could not supply DALI fixtures in the timeline that the project needed, which gave us 2 options. Option 1, switch manufacturers, pay 4 times the cost. Option 2, change from DALI to 0 to 10 volt. Does anybody have any idea what happens when you bid a project in DALI and then say, oops, I'm sorry, just the fixtures in my entire pathway are going to be 0 to 10 volt? So what happens is that the electrical contractor loses their mind. And I'm only joking a little bit, because when you use a digital protocol like DALI and you want to build circuits right? So an electrician's job is to pull wire to get power from the panel to the fixture, right? That's all they do. It's essentially, I'm not denigrating the craft of electrical contractors because they're very important. But it's essentially you're running extension cords, right? You're taking a piece of wire from the panel, from the electrical panel, and going to a fixture. All right. When you do this and you are looking at DALI, you start at the beginning, you start at 1, and you add up loads until you get to 1,200 watts. That's approximately, or 1,000 watts, depending on the amperage of your individual circuits, right? That's the amount of power that your circuit is allowed to control. The reason you can do that is because in a DALI system, each individual driver is individually addressable. That's the digital addressable part. That means that if I have a fixture here and a fixture here, even if they're wired on the same circuit, I can talk to them individually and I can control them separately. All right, cool. Why do I care? You care because in a standard situation, like a 0 to 10 volt situation, which is what electricians are most familiar pulling, you can't do that. In a 0 to 10 volt situation, if you have 2 fixtures on the same electrical circuit, they're married for life. Like, you cannot break them. There is nothing you can do to make them operate separately. Not exactly nothing. Well, in 0 to 10 volt, there's nothing you can do, right? If they are together, they are together. They're that same thing that we looked at the very beginning with the piece of wire going to the different groups. So there are ramifications that go along with describing a system one way and building it another way. In this case, it was a $40,000 change order from the electrical sub. Yeah.
Have you used a DALI to 0 to 10 driver?
Well, the manufacturer was committing, because remember this was a super compressed time schedule, was committing to providing straight 0 to 10 volt. That was the driver they had on hand. That was what they could provide. So it was either wire these fixtures at 0 to 10 volt or wait for them to come in. And for a little while, the general contractor said, you know what, we'll just wait. We'll just put these up after. At which point, and it really shouldn't have had to have been the lighting designer who said this, but it was me. I raised my hand and I said, how are you going to get a certificate of occupancy with no downlights in your hallways? And they said, we hadn't thought about it that way. And I said, okay, so remember when I said that if we don't do it this way, it was going to be a problem? This is the problem I was talking about. Now, in the end, we did, in fact, go 0 to 10 volt, and that was what happened, and that was the way it went. Does that make sense to everybody? Does everybody understand why that has implications for control and control documentation? Okay, cool. So the rest of the fixtures on this project are pretty standard, although I will say that this was also kind of an interesting little thing, and I learned a really important lesson about this too. We started out as the basis of design for this project was tunable white, dynamic white. Everybody understands what that means, right? I can show you if you're not sure, but in fact I will show you because I will. So this is a tunable white fixture. No, this is a warm dim fixture, I'm sorry. This is a tunable white fixture. So this fixture, sorry, I don't mean to blind anybody. Can everybody see that this has multiple color temperatures that live within it? This particular one is a DMX driver, so it's addressing the warm diodes and the cool diodes separately. Let me turn it this way without blinding people so that you can see. So you can control it. It's also flickering, I apologize. All right, another way to do this, here's very warm. Another way to do this is to use this is a 0 to 10 volt version, to use 2 different zones. This one is for intensity and this one is for color temperature. It's the same basic idea, okay? So our basis of design for this project was tunable white. The first time we went out to bid, the manufacturer of this fixture priced the tunable white DALI fixtures at 3 times the cost of the static white fixture. So this time, it wasn't the electrical contractor that lost their minds, it was the owner. And when I tell you they lost their minds, I really do mean they lost their minds. It was like their heads had exploded. So 2 things happened. The first thing that happened is there was a massive explosion, and then we cut all of the tunable everything and all of the whiz-bangness, and I thought, oh, this is going to be such a boring project, and also it doesn't meet the 14 other things that you said were important to you. Remember, there was this whole neurodiversity thing, there was the environmental thing, all of that. So then I had to think about it, and I came up with a solution, and the solution was daylight modulated fixtures, they don't actually need to be tunable white. Why? What's special about a daylight fixture, a daylight controlled fixture? What's special about a fixture in a daylight harvesting zone? Let me rephrase that. They're off most of the time, right? Think about it for a second. During the day, these fixtures should all be off. So, as long as the color temperature of those fixtures is one that will not affect people's circadian rhythms, that is, as long as it is on the warm side, because in the evening is when we need warm light, it doesn't really matter what the color temperature is, whether it actually passes through the whole sequence during daylight, because the goal is to have them off. That's why daylighting is required by code. It's an energy conservation manner. So this was actually a learning moment for me in that, yes, would it have been better to have kept with a tunable white dynamic, fully dynamic fixture so that we could be completely attuned to what was going on outside? 100%. That being said, since even exciting whiz-bang projects have real-world budgets, sometimes you have to compromise. So the compromise here was to make the things that are in daylighting zones not tunable, but warmer. Okay? So here's this is the whole family of fixtures. And this is what my control intent looks like. Now this is a graphic version. There's also a written version. We're going to look at that in a minute. Can everybody basically understand what's going on here? Do you want me to explain? I can walk you through it. But I think I hope it's self-evident. Well, I'm going to walk you through it anyway, because that's why I'm up here. All right, so you can see there's a color down here, and each one of these spaces has a color, right? Obviously, it's a color-coded diagram. We all know how those work. So what I've done over here, and I don't know if you can read this, because it is kind of small. I can't read it, and I wrote it. All right, so this says the entry sequence is time clock with occupancy override. So that's that time, that's where it comes on in the morning and stays on, except when it goes off to, in this particular case, I believe it goes off to 30% if it doesn't detect occupancy, and then at night it goes back on again. The quarters are also time clock with occupancy override, but slightly different. The open office is daylight time clock and occupancy override. We got 3 things going on. The daylight controls the intensity, the time clock controls whether or not it's enabled to come on, and then the occupancy override keeps people from working in the dark. One of the things that I spend a lot of time thinking about, and this is a gender-based thing, I'm going to say that now, I don't want to be in a dark space. I don't feel safe in walking into dark rooms, and I don't think anybody should have to walk into a dark room. So one of the things that I spend a lot of time thinking about is, what happens if I'm the last person in the office? What happens if I'm alone in the bathroom? What happens if I have to go into the storeroom alone? So one of the things that is it's a hallmark of the way that I work in my projects is that I spend a lot of time thinking about this, and so I almost always have an occupancy override somewhere, whether it's a manual thing so that you know where the switch is, or, for example, in the public restrooms, the slot at the back wall. So in my public restrooms, this is, telling you all my secrets. I usually put a slot that goes along the wall where the stalls are. That slot is always on at least 30%. Because nobody should ever have to walk into a dark room, because it doesn't feel safe. Whether you're a man or a woman, it doesn't always feel safe. Okay? All right. So this is actually my control intent narrative. So I start with a little bit of a purpose of this document. I define all of my terms, and you'll notice down here, this is page 1 of 13. It's not an easy read, even though I did write it for my mom. It's still not an easy read, and when I tell you that I sent this multiple times to the owner's rep and said, please, will you please make sure that somebody reads this? And when the whole pricing thing started going haywire, she said, well, how were we supposed to know what we were supposed to read? Yeah. So this, and this is kind of interesting, this is what the engineer did with all of that information. So on the plus side, all of this is, yes, completely copied from my control intent narrative. And I'm going to tell you, I'm going to let you in on a little secret. I actually use the word shall in my control intent narrative for just this reason. And I actually, somewhere here, you can't see it because it's too small. Somewhere in here it says, every set point that's noted in this document and from here on out is assumed to be adjustable. For just this reason, because I have never met an electrical engineer who, when faced with this, will then actually go back and perform the documentation necessary to write a sequence of operations. So the learning moment for me in this is to not mess around with, well, here's my intent. Can't you help me put together a sequence? I should just do the sequence because this is what it's going to do. The other thing that's kind of interesting is, as cool as that document was in multiple colors, it's useless in black and white, except for the fact that I did spell out what's going on here. So this was the point at which I was going to tell you what happened when I went to the job site and we went to program this huge DALI thing. But as I said, they're moving in November, and I haven't been to the job site, and I can't tell you. I can tell you that we did manage to keep the DALI, that we kept tunable white on the interior spaces along the lines of people who didn't have access to daylight, and I can go back and show you what that means. Let's go back. Oh, that was actually the one. So all of these spaces here, these conference rooms, and these touchdown and huddle spaces, they all maintained their ability to be tunable white, so that if you went into if you left the daylight space, which presumably keeps you entrained because there's so much daylight, and then you move into one of these quiet huddle spaces or touchdown spaces, you're not thrown backwards in a different direction. So that was sort of our half and half solution to this. And that is all I got. Questions? Yes?
I don't have a question, I do have a comment, and that is, while you were up there doing all your hocus pocus, I sent a text to a lawyer friend.
Uh-huh. Oh, about shall?
He has never had that question. I don't know what kind of lawyer he was. But he responded that shall would be very specific, whereas something like should is very vague.
Okay. So that's a good answer. Yes?
With this project you're just walking us through, it was under construction. Did you have any pre-construction meetings with the subs or
Uh-huh.
contractors about Dolly, right? They presumably don't know it, so.
So what's one of the cool things about working in major urban areas is that the contractors do tend to be slightly more sophisticated. So nobody freaked out too much on the contracting side when I said I was going DALI, but there was a pre-construction meeting, and actually in my control intent narrative, and this is covered in the document also, I have a whole paragraph about how the contractor is responsible for following the manufacturer's timelines and making sure that if they require pre-con meetings, that they calendar them. There's a whole thing that says you have to give me 5 business days warning before you want me to come and show up at your site. And if you can't do that, and you can't figure out a way to get me and the startup people on the site at the same point, you can't ask the owner for more money because it's not the owner's fault, it's yours. So all of that is included actually in my control intent narrative, and that's part of the reason that it is voluminous and extends to 13 or sometimes 20 pages, because I think most lighting designers who have worked for a while will tell you that there is a story behind every single note on their schedule. That's why. Other questions? Yeah. Yes, you can. I'm sure that, I'm fairly sure that the show will give them to you, but if not, I will be happy to give you my card and I'll be happy to share my slides. Anything else? Oh, I didn't give you my pitch for being on IAS technical committees. You should be on IAS technical committees. If you haven't been on an IAS technical committee and you're first of all, you should be a member of of both the IAS and the IALD. They are two different organizations for two different purposes. If you're a lighting designer, you should be a member of the IALD. And you should also be aware of and perhaps join the IAS. If you're not a lighting designer, if you're an engineer or a contractor or a rep or something else, you should join the IAS. In any case, you should be on a technical committee because they are great networking opportunities and they're hugely beneficial in terms of learning how to be a subject matter expert in anything, including color. Other questions? That's all I got, folks. Thank you very much.